Hello, my name is Simon Timper from the International Food Safety and Quality Network. Today we're here with Tony Connor, our good friend. It's not Friday, it's Wednesday, I think. So what are we doing here? It's a new thing we're trying. It's called Food Safety Essentials, where we'll have a topic. We will have a short presentation and hopefully have some good discussion and Q&A. The reason being is that, we enjoy doing it and there are only so many Fridays in the year. So what we're going to do, we're doing this one as a pilot, hope to do another one in December, and next year, if they're successful and well attended, we might move to 2 a month and then even 1 a week. So it depends if there's demand for it and if you enjoy it and get a lot out of it, and we can grow this. You will get, as usual, a recording afterwards, and also we've created a certificate of attendance as well. So anyway, welcome, Tony. How are you doing?
Hi, Simon. Thank you. Hi, everyone. I'm fine. Thank you. Yeah.
And today's topic is?
Food safety recalls and what the data tells us.
Okay. Yeah, and we've got 984 registered. We've got 133 live with us right now. I'll be joining in with a Q&A. The presentation's how long, Tony, roughly?
It's about 20 minutes. And then we'll do Q&A on the Q&A on the presentation, but we're happy to throw it open and answer questions on any other food safety related topic, if you like.
Sounds good.
Okay.
You're programmed to do it. You all know, tell us where you're joining from in the sidebar. It's always good to see. Susan from Iowa, Albert from Texas, Marius from South Africa, Roy from Philippines, Ravi Kumar from India. So, okay.
Yeah.
Over to you, Tony.
It's also useful to know what products you're working with. So if you could type that in the sidebar as well, that'd be useful to know. So we can discuss anything relevant after the presentation.
Sounds good.
So here we go. So welcome to this first ever Food Safety Essentials session. We're going to split the time between this presentation and a Q&A session. And today's topic is what recall data tells us about the food industry and what we should do about it. So this is my slide from Food Safety Live in 2013. 60% of recalls were related to allergen management, labeling and information, and all but 2 of the others from environmental pathogens. In 2020, out of 879 recalls, 53% were due to labeling and undeclared allergens. 2022, a third of all recalls were due to pathogen contamination. And onto the latest data, which is between 2021 and 2024, which shows 353 recalls due to problems with labeling and undeclared allergens. Out of 771 recalls, 46.4% were due to labeling and undeclared allergens. And 226 recalls were due to problems caused by environmental pathogens, Salmonella and Listeria. 29% were due to these. So over 75% of recalls are due to problems caused by either labeling or undeclared allergens or by product contamination with well-known environmental pathogens, Salmonella and Listeria. So these are the 2 biggest issues in the food industry. Today we're going to focus on environmental pathogens, Salmonella and Listeria. And next month we'll look in more detail at labeling and undeclared allergens. So, as it's topical, there has been 2 massive Listeria-related food safety incidents this summer. and there have been 10 deaths from the boar's head outbreak. Over £7 million of ready-to-eat meat and poultry products were recalled. There were 59 hospitalizations, and there's an ongoing CDC investigation. There was also a massive recall of Bruce Pack ready-to-eat meat and poultry products, where nearly £12 million in total were recalled. The products were delivered to an extensive list of customers. The distribution list for recall was 409 pages long. So, poor supplier approval and raw material monitoring controls can result in Listeria and Salmonella contamination of finished product. Inadequate processing can lead to Listeria and Salmonella surviving and being present in the finished product. Bacterial pathogens can be introduced into a processing facility where the pathogens then become established in a harbourage site, multiply, and persist for extended periods of time, even years. A harbourage site is a site in the environment or on equipment such as junctions, cracks, holes, and dead ends that enable the accumulation of residues such as food, debris, dust, and water, and permits the growth of microorganisms such as Listeria monocytogenes and Salmonella. These sites may be difficult to inspect or access and therefore can protect environmental pathogens during routine cleaning and sanitizing. Of all the bacterial pathogens, Salmonella and Listeria monocytogenes have the most extensive history of being able to set up residence in a processing facility. While common cleaning and sanitization practices are adequate to control the presence of transient contaminants, such practices do not control the presence of resident contaminants once they have become established. Once an environmental pathogen has become established as a resident strain, there is a persistent contamination risk for foods processed in that facility. The facility will need to use intensified sanitation procedures to eliminate the contamination. Listeria monocytogenes can contaminate foods and cause a mild, non-invasive illness called listerial gastroenteritis, or a severe invasive illness called listeriosis. Listeriosis is characterized by a relatively high mortality rate compared to illnesses caused by most other foodborne pathogens, 20% compared to less than 1% for Salmonella or E. coli 0157. Salmonella. Water in dry processing environments is one of the most significant factors for Salmonella contamination. This is because water allows for pathogen growth, significantly increasing the risk of product contamination. Water present, even in very small amounts for short periods, may allow Salmonella to grow in the environment. Harbourage sites may develop and become a source of contamination unless the sites are identified and eliminated. Pathogens such as Salmonella can be difficult to control in a low-moisture food operation environment because they can persist for prolonged periods of time in a dry state and in low-moisture products. For Salmonella, the infectious dose is thought to be very low, as demonstrated by the small number of cells per serving recovered from low-moisture foods implicated in outbreaks. There is evidence that the composition of a food, especially high fat content, may protect Salmonella against the acidic conditions in the stomach, potentially increasing the likelihood of illness from consuming low numbers. After this Cadbury's outbreak, Professor Hugh Pennington of Aberdeen University stated that the only safe level of Salmonella in chocolate was 0. So food composition can affect water activity change in chocolate products at elevated temperatures. At 80 degrees, salmonella exhibits higher thermal resistance in white and dark chocolate, which have fat contents of 53 and 74% respectively, compared to milk chocolate, which have a fat content of 41.8%. In this incident from 2022, 35 tons of chocolate was destroyed due to salmonella contamination. Selected salmonella outbreaks associated with low moisture products include chocolate, milk powders, nuts, cereals, herbs and spices, peanuts, and peanut butter. You should also consider dried fruits and vegetables, dried protein products such as soy protein, seeds for consumption such as sesame seeds, when these foods are used and not subject to a microbial inactivation step. So these are further examples of pathogens identified from outbreaks, including chocolate, peanut butter, and white pepper. These are examples of outbreaks with listeria, including butter, cantaloupes, and soft cheeses. Past listeriosis outbreaks in the US have been linked to raw unpasteurized milks and cheeses, ice cream, raw processed vegetables, raw processed fruits, raw or undercooked poultry, sausages, hot dogs, deli meats, and raw smoked fish and other seafood. This is a table of potential sources of Listeria monocytogenes and comes from Guidance for Industry. It identifies potential sources in ingredients, which you just mentioned, potential sources from processing materials such as air, ice, and brine solutions, potential contamination from contact surfaces such as conveyor belts, filling and packing equipment, belts, peelers and collators, containers, bins, tubs, slicers, dicers, shredders, blenders, utensils and gloves. Also potential sources that do not generally contact foods, such as equipment framework, wet, rusting or hollow framework, poorly maintained compressed air filters, condensate drip pans, for trucks, hand trucks, trolleys, vacuum cleaners and floor scrubbers, tools for cleaning equipment, freezers and ice makers, and potential sources of listeria from the plant environment, floors and walls, especially where there's cracks and crevices, drains, ceilings, overheads, catwalks, wash areas, wet insulation in walls or around pipes, and contents of wet vacuum cleaners. These are scenarios that could lead to contamination of ready-to-eat foods with Listeria monocytogenes. A packing line is moved or modified. Used equipment is brought from storage or another plant and installed into the process. Construction or major modifications. A new employee unfamiliar with the operation and Listeria controls and has been hired to work and clean in a ready-to-eat food area. Heat exchangers that have become compromised, such as with pinholes, equipment parts, tubs, and screens being cleaned on the floor, recirculating pumps and lines not cleaned and sanitized, indiscriminate use of high-pressure hoses in cleaning, inappropriate use of foot baths in dry processing areas. These are a few examples of foods processed in wet and dry areas, but I'm sure you're all aware of these types of products in wet: ice cream, dairy products, salads, frozen meals, beverages. In dry areas, salmonella powders, dehydrated soups, powdered beverages, nuts and nut products. On to prevention of contamination. Sanitation controls, including proper personnel practices and equipment and facility design, are key to preventing transient bacterial pathogens from becoming resident strains. Pathogen control elements include applying hygienic design principles to the building and equipment design, establish a raw materials and ingredients control program, establish good manufacturing practices, prevent ingress or spread in the processing facility, enhance the stringency of hygiene practices and controls in high-risk and high-care areas, prevent or minimize growth of the pathogen within the facility, validate control measures to inactivate the pathogen, establish procedures for verification of pathogen controls and corrective actions, investigations from salmonella outbreaks indicate that safety of low moisture foods depends fundamentally on the control of salmonella in the food operation environment. Maintaining good hygienic practices, hygienic design of equipment, proactive maintenance program, control of incoming materials, and effective ingredient control in a low moisture food environment will help prevent the contamination of low moisture foods with pathogens. Special attention should be paid to those products that are exposed to the processing environment following a pathogen reduction step, such as cooking. Products that are not subjected to a pathogen reduction step and products for which ingredients are added after the pathogen reduction step must be controlled. So, internal design and layout of a food establishment should permit good food hygienic practices, including protection against cross-contamination between and during operations. This is particularly applicable to high-care and high-risk food facilities where adequate segregation of high-risk foods from contamination is required. Separate changing facilities should be provided for personnel working in high-risk and high-care areas. The flow of product, personnel, services, and materials should be such that they significantly reduce the risk of product contamination. Internal structures should be soundly built of durable materials and be easy to maintain, clean, and where appropriate, be disinfected. Personal hygiene standards should minimize the risk of product contamination from personnel and be appropriate for the products produced and adopted by all personnel. Suitable site-issue protective clothing needs to be worn by employees working or in entering product areas. Relevant verification activities should be implemented to check that good hygienic practice procedures are effective, monitoring is occurring as planned, and that appropriate corrective actions are being taken. So we need to have good manufacturing practices, and clearly cleaning and sanitizing is one of the most important aspects of that. And your procedures should include approved cleaning and sanitization agents and tools, appropriate cleaning and sanitization programs and procedures. I find it useful to use photos in standard operating procedures and work instructions. It's important that all parts of the facility are clean and free from contamination, but this is even more critical with food contact surfaces. CIP, or clean-in-place systems, and adequate facilities should be suitably designated and provided for cleaning food, utensils, and equipment. Where appropriate, facilities for washing food should be separate from facilities for cleaning utensils and equipment, and separate sinks should be available for hand washing and food washing. Automated cleaning can provide more effective, consistent standards of cleaning. A separate area should be provided for tools and equipment that are used to clean highly contaminated areas such as toilets, drainage, and waste disposal areas. Sanitation systems should be monitored for effectiveness, periodically verified by means such as an audit, pre-operational inspections, or where appropriate, microbiological sampling of the environment and food contact surfaces, and regularly reviewed. The use of ATP swabbing is an effective method of monitoring cleaning effectiveness and is very quick. An acceptable and unacceptable level of cleaning performance should be defined for food contact surfaces. Environmental monitoring. You should have a risk-based environmental monitoring program in place for relevant pathogens, spoilage and indicator organisms. Swabbing locations and methods need to be clearly defined and documented. This is an example of an environmental monitoring schedule where we've got weekly and monthly swabbing there depending on the areas. Food contact surfaces are prioritized, but the environment is also monitored, including floors, walls, and drains. Also note that when applicable, you should also monitor air systems, such as HVAC, and filter fines for salmonella as part of your environmental monitoring program. Obviously, when salmonella is an appropriate environmental pathogen. Your environmental monitoring program needs to be reviewed for continued effectiveness and suitability. Also when there are significant changes, such as to products, processes, or equipment. You should investigate when you have no positive testing results over an extended period of time. You should trend out of specification microbiological results related to both intermediate and finished product linked to environmental monitoring. When there's a detection of pathogens during routine environmental sampling, you should obviously investigate. And when there are alerts, recalls, or withdrawals related to products produced by the organization, so if you've had a product positive. These are examples of action you should take from the industry guidance for control of listeria and for food contact services. For the first positive, clean and sanitize the area, retest during the next production cycle, conduct a comprehensive investigation. Second positive, intensify cleaning and sanitizing, including disassembly of equipment, intensified sampling and testing, hold and test product, reprocess, divert, or destroy product and hold if positive, comprehensive investigation. Third positive, stop production and consult exports for comprehensive investigation, intensify cleaning and sanitizing, which is escalated, such as to steam equipment. Resume production with product and hold and test until 3 consecutive days of product and food contact surfaces are negative. Okay, so that's the end of the bit about environmental pathogens. Next time we'll cover labeling and undeclared allergens. So we'll talk a bit about allergen management, product information, labeling, and pack control. So we're on to questions and answers, if there's any questions.
Only one for now, but we invite your questions. Should we get rid of the slides? Yeah, there we go. Just before we get onto that, we neglected to say at the start that these webinars on a Wednesday, these food safety essentials, will be just Tony and myself, so they won't be different presenters each week. So it will be a cozy presentation and some chat Q&A with you. So yeah, just thought I'd clarify that, because it is a different way of doing it than Food Safety Fridays, where we have a range of different presenters each week. Yeah, so Michael's asked this question: wooden pallets, the potential.
I've lost the camera, and can you hear me, everybody?
Yeah. Can you hear me? Can you hear me, Tony?
What did you do then, Simon?
Can you hear me? I don't know what's going wrong. Are you there, Tony?
I'll try logging in again. I think.
Yeah. So just type in, can everybody see and hear me? I mean, I could still hear and see Tony as well. But he's going to log off and log back in. So yeah, do pop your questions in the sidebar. Hi, Tony.
Hi, I'm back. I don't know what happened there, but
yeah, well, I think we could all see and hear you, but you couldn't hear and see us. Anyway,
yeah, right, I'm back. Okay, so the first question I saw was pallets. So when you're controlling your environment, let's say you've got a cooked product that's ready to eat. You're going to cool it and pack it. So what you'd normally do is post cooker is your high risk, high care area where you want to control that environment. So you wouldn't want pallets in that environment particularly. So normally you'd pack it, your product, or fill it, or whatever you're doing post cooking or post pasteurization. And then it would go through a wall into an area where you would allow pallets to be stacked. So pallets are a no-no in high-risk areas, basically, unless you've got something that's dedicated to that area, such as a plastic pallet that can be washed appropriately.
Okay, there's another question from Cindy. You talked about APT swabbing. We used that and went to Coleman Lumi Tester Smart for better results.
Yeah, that's. I mean, I'm not familiar with the name, but that sounds like the same sort of technology. And you know, I've been using ATP technology since the 90s. It was a fantastic tool for improving product quality, and I think that's the same sort of thing. So, yeah, there's a lot of different. I mean, there's only two main manufacturers when I started out, but there's a lot more now. And yeah, I mean, if it's ATP based technology, then I think that would be fine.
Okay.
Yeah.
Any further questions? If not, then okay, yeah, Anna, that's good. Sorry, let me just grab that.
It's also useful to know what products people are working with. If there's anything, then we can see if there's anything relevant to what we're talking about.
Just hang on 1 second. So a question from Anna. Question for EMP. Should we swab for pathogens in food contact surfaces? How to behave when we find positive in non-direct food contact zones?
Okay, I mentioned a bit about that in actions when you get a positive. So Should you swab the pathogens on food contact surfaces? Yes, but you probably don't need to swab as much if it's free, if your environment's free from there. So if you get a positive in your environment, you start increasing your testing. If you're investigating, but if you're not getting anything on your food contact surfaces and only very infrequently in the environment, then you would reduce the amount of testing of pathogens and probably monitor for enteros, which will pick up include the likes of salmonella and TVC and yeast and mold. So you would do more routine sampling, which tends to be much less expensive and less pathogen testing if everything's in control and you're happy.
Question from Rebecca.
Oh, sorry, can I just finish off on that? Because there was a second part.
Yeah.
Second part to that. How do you react if you do get a positive? There's investigation. You need to clean. You need to do further swabs in the area where you've got that positive and try and track down the source of it. So intensive cleaning certainly, and further follow-up swabbing. Not routine swabbing. Follow up to your positive. Okay, sorry.
Okay, thanks. Sorry about that. Question from Rebecca. Could you talk about the exceptions of having EMP?
I don't know what you mean by that. Could you explain?
Yeah, maybe expand on your question if you can.
Yeah, I don't know what you mean by exceptions. If you mean that if you've got a very low risk food, should you still be monitoring the environment? Probably yes, but to a lesser degree compared to ready to eat products that support the growth of pathogens, where it's vitally important, as you've seen from the recalls with cooked meats and poultry. Listeria grows at refrigeration temperatures, and so those products are considered quite high risk.
Okay. Thanks, Tony. From Chris Hack, how will you be sure and also address raw and packaging materials contamination from vendors, considering your absence during their process handling during production of their materials?
Okay, this would all come. Hi, Chris Hack. Thank you for your question. This all comes down to supplier approval and monitoring. So depending on the risk associated with the material. So if you're putting an ingredient you're buying from somebody in a finished product, so if you're putting, let's say, chocolate chunks on top of a cooked cake that you're buying in, then you're not having any microbial control on that. And so your supplier approval and monitoring procedures need to be very strict. If you've got a process where you're processing and destroying the pathogen by cooking, so salmonella and listeria both killed by cooking or pasteurization, then your controls don't need to be as stringent. But where you need to have stringent controls, supplier approval as required by GFSI benchmark standards, BRC, SQF typically are certified to the standard. Your site certified to the standard. The scope includes what you're supplying, or an on-site audit, which includes food safety, GMPs, by a fully competent auditor, and you're required to, for high-risk products, review that report and keep a copy of it. So that's how you would handle, and it's all down to supplier approval. Now, if you were especially concerned, and I would be with chocolate, I'm putting on top of something that I'm not controlling the pathogen, I haven't got a pathogen control step on, then I would be sampling the product coming in and positively releasing it before I use it.
Okay, thank you. Question from Rayan. What are some good sites to swab? I find presumptive listeria sometimes in non-food contact surfaces, and the sanitation supervisor brings up how it is not a food contact surface.
Yeah, but okay, thank you for that. Because let's say at some stage during production you might have some contamination, but I particularly wouldn't bump this listeria. But if you're doing swabs as well when you're after cleaning, then regardless of what the surface is, there shouldn't be listeria there. So if the procedures are correct and being followed, and the detergents and sanitizers or disinfectants are correct, and you're still getting listeria, then there's a problem. And the whole idea of this environmental monitoring is to detect the problem before it gets to food contact surfaces and then gets to products. So you want to stop it in the environment before it gets to your food contact surfaces and then products, and that's the principle behind it.
Okay, makes sense. Question from Rosiel. Can you recommend the ppm of calcium hypochlorite for sanitation?
Not offhand. I would think it's about 150 ppm, but you should always follow the guidelines that are given or instructions on the chemical supplied, okay, or from your chemical supplier, and that they should give you direction on what concentration to use your chemicals. But something at 150, 200 ppm maybe for disinfection. Some people use it in water, but it's in a much lower concentration, a couple of ppm maybe.
Yeah. Okay. Question from Rayan. I work at a soup plant. I am always swabbing drains. The fill tech, what the soups get filled inside of. I swabbed Mersen pumped kettles that the soup get cooked in. Is that? I'm not sure if it's a question or.
No, I think it's more of a statement. But yeah, you could drains, environment, walls, floors, where it's cooked. Okay, but your cooking process should kill any pathogens in that soup. But also for food contact surfaces, post cooking, I would be looking at wanting to do any areas, because you're going to go from that, presumably from your cooking vessel to a tank, or directly through a line to a filling machine, and maybe you're going to fill tins or glass jars or whatever. So the post cooking surfaces are the ones I'd be really interested in monitoring. So post cooking, post pasteurization, food contact surfaces, because that's where the greatest risk of salmonella or listeria contamination affecting your product, because if they're in the cooker, they should be killed by the cooking process.
Okay. Question from Mahendra. How often should we test the compressed air from our compressor for microbial contamination if it comes into contact with rice before packaging?
All right. Well, I think you'd have to validate that you're happy with your air in the first place, and your validation should tell you, data should tell you how often you should be monitoring. If you've never had a problem, then maybe you should only be doing it, say, weekly. But if you have regular problems, then maybe you need to be doing it daily. It depends on the history of the plant and the compressor and your whole system. Okay.
And just to follow up on compressed air while we're on it, Abby Manu, how to verify compressed air in daily operations?
I think I'm not an expert on compressed air. I mean, you can do it by air samplers and whatever, but there's plenty of resources, and one of the sponsors, I think, is supplies or talks about compressed air on the IFSQN website. So I would go and look at one of those webinars to discuss it. But generally, I sample air through an air sampler or an exposed plate, an exposure plate.
Yeah. In the follow-up email, I'll put a link to the archive of Food Safety Fridays webinars, and Trace Analytics, as Tony said, are one of the sponsors of IFSQN, and they've done a number of webinars on compressed air, so it might be worth taking a look at that. Question from Paul: do actionable sources or any non-target organisms?
You break it up a minute there. ATP swabs will detect. No, it's okay. It's not your fault. ATP swabs will detect ATP from any source. Yeah, so they work on bioluminescence on reacting with ATP, and ATP is present in living cells, so it'll detect ATP in food debris, but it'll also detect ATP in bacteria. But vegetable sources, yes, as well.
Okay, can you hear me now?
Yeah.
Okay, from Kavita: in fresh produce processing, ready to eat fresh cut veg, if the raw material is detected positive for Listeria spp, not necessarily mono, but to a level of 10 CFU, what can be done then, as by the time results are out, the raw material has already been used as part of the process, raw material is washed to get a 1 log reduction in TVCs?
The raw material has been used for what? You mean it's been sent out, or it's been oats? It's a ready-to-eat fresh cut.
Yeah.
I think if you've had a positive, my immediate thinking would be look to be doing a hold and release, positive release on your product. Consider withdrawing the product and possibly recalling it. In the meantime, you obviously want to do an investigation. I know you're saying it's not necessarily mono, but it's a worry that you've got a positive Listeria in there. There's plenty. Oh, sorry. I can't hear you, Simon.
Sorry, apart from Listeria and Salmonella, are there other foodborne diseases that pose dangers to the food industries?
Yeah, well, there's quite a lot of other foodborne diseases. Other common ones are Staphylococcus aureus, which is a toxic producer. Tends to be more of a problem in fermented products where the bacteria grows and produces a toxin that's not destroyed by cooking. Clostridium botulinum in canned foods can be a problem. Norovirus is a virus that's a problem. Campylobacter, E. coli 0157. There are other E. colis. So, yeah, there's quite a few bacterial pathogens. There's also potential viruses and toxin producers.
Okay. Question from Margaret. What is the ATP threshold accepted by food industry as failing?
Right. Okay. Well, it depends. This depends. Thank you for the question, Margaret, because it's quite a good question. It depends on the equipment you're using and so the testing equipment you're using, but also the services you're testing. And the way you establish ATP in your facility is to do a series of validation exercises where you check surfaces after cleaning. You take a microbiological swab, which you test for TVC, enteros, yeast and molds, and you take an ATP reading. And let's say, and this is how I first introduced it in the facilities I've worked at. You establish, say, a month's data, and you get to know what levels correspond to what you believe to be a clean surface, and it can vary with the surface and the equipment. So you establish your own levels, and then establish a pass let's say, a warning level and then a fail. And now on the old systems, it used to be less than 10 was a pass, let's say, and over 100. But these are relative light units, so it can vary from test to test and the type of equipment you're using. So, yeah.
There are a couple more questions on compressed air. Maybe you can shed some light on them, I don't know. Rod, with compressed air systems, do you have filters at point of use?
Yes, certainly you should have. And certainly if you're using the air for contact with food or food contact surfaces, but every standard I read say filter at the point of use.
Okay, and another one on compressed air from Tiffany. Would testing the compressed air be necessary if we sanitize the area equipment after cleaning with compressed air?
Hi Tiffany. I would still want to test my compressed air periodically, because you don't want to have a clean surface and then add contamination. So I'd want to test it, but less so if you're less frequently, perhaps, if you're sanitizing the equipment and area.
Question from Chisak. Do you have any documents that will serve as a guide in handling manufacturing process to prevent product contamination? Kindly share with me.
I think if you look on the US government websites, they have quite a lot of guidance for industry in there. So I would look there. There's quite sound advice there, but so that there's a few guidance for industry related to FSMA, and also I pointed out some data from control of listeria. But other than that, there's also codex, have lots of codes of practice and guidance. So if you looked up codex there, they've got, for example, they've got a code of practice for the control of low moisture foods, such as salmonella. Yeah. There's plenty now. We've got the internet. There's plenty of resources out there. Yeah. So, yeah.
Another question similar about resources for vulnerability assessment for food defense. I can actually give a plug there because Vladimir Sachinsky, who's one of the presenters who do Food Safety Fridays, but also this week did a practical food safety culture training, a very good TASUP, VASUP webinar, 4 hours, and that actually gives links also to various resources and provides a lot of documents and templates that can help you. So it might be worth, I think in the follow-up email, I'll put a link to that as well.
Yeah, but there are, again, I think it's Michigan University that has there are some tools that are out there for free if you search on the internet.
Yeah, I more meant that to give you like a good overview as a hub to link you out to lots of different resources.
Well, yeah, by all means, if you can afford $97, I presume it's $97, and that's probably quite a good option. But if you want it free, have a look at the resources that offered.
Yeah,
I think it's Michigan University.
Okay. Question from Shiela. If testing never results in a positive, it was seen that perhaps we're not testing the correct places. How long between negative results should we reassess testing locations?
I think if you went 6 months, I mean, if the product's clear, your product's great, microbiological results are all good. I think if you got to 6 months without a positive, I'd probably have a look at a few other places.
Okay. Any more questions? We've gone through all of the ones that were listed. So any more questions on any topic, whether it's product recall or anything food safety you want to ask Tony while he's here? In the meantime, shall we put the offer in for the that we've got?
Why not? You're going to do that, Simon? Yeah,
I can. Was it on a slide as well or not?
Can do. Should I do the slide?
Yeah, I'll put the offer in the sidebar, but also you can. Oh, there we go. Anyway, yeah. Yeah, it's in the sidebar.
I don't need to do the slide then, do I?
No, you can leave that.
No, yeah. Okay, so we've got a promotion on for our range of implementation packages, which cover all the main standards for GFSI benchmark standards. The packages tend to include food safety management system procedure templates, good manufacturing templates, training, a tool we call the HACCP calculator, which is in Microsoft Excel format that allows you to do your whole hazard analysis, assessment, and determine critical control points in one spreadsheet. There's HACCP training in there, short HACCP training presentations for the sites, internal auditor training, lots of other assessment tools in there, a complaint analyzer helping you reduce complaints, and quite a lot more.
Yeah. So on that, only on this training is it available. So it's 15% off all of the different. And if you click find out more, it'll open a page and you can see the range of manuals for BRC, SQF, FSC 22000, etc. So 15% offer to everybody, and the code is there underneath. Only for food safety essentials, FSE November 15, and that's available for the whole of November. So just grab that code and paste it somewhere, because it won't be shared anywhere else. And then just go and have a look at your leisure if you're interested, and you can always contact Tony if you need any information on any of the packages and the contents, etc. So, question from Victor. Could you share ideas on how to set up traceability in food manufacturing?
Okay, so for traceability, you need to be able to trace from the supplier to all the way through your process to the customer. So you start off who you're buying from. You should have documentation from that. What are you buying? Raw material. So yeah, you've got records for that, purchases. You have incoming goods records. So you should have traceability for this product you've purchased that comes in. It's got a batch number, and then you should be able to follow that raw material through your process. So you go raw material, maybe mixing, processing. At each stage, you need to be able to follow this batch. So when you mix, maybe you create a unique batch number related to that day and that mix. Then the processing, that batch number needs to be recorded. Then you might fill the product. So it needs the batch number needs to be recorded for filling, for packing, for stacking, for storage in the warehouse, and then dispatch, record the products, finished products, and the batch number that you send to your customers on which vehicle. So traceability from raw materials coming in to finished product dispatch to customer.
Okay, do you have a question? Thanks for that, Tony. From Abdul. How can we ensure the listeria-free status of canned water chestnuts, particularly those imported from the Far East and preserved in water?
Where's that? Is that popped up, Simon? Or
yeah, it's in. Let me just highlight it. There you go.
Okay, thank you. Yeah, I couldn't see it. List it. Canned water chestnuts. If they're canned, I'm assuming they've gone through a canning sterilization process, and if they have, then I mean, something would be seriously wrong if listeria was present in there. But obviously, you can get certificates of conformance or analysis from your supplier, and periodically test yourself. But I mean, unless the can is damaged or leaking, I don't, and it's been subject to a sterilization process, and I don't see how it could have listeria in it. Yeah. So sampling, I mean, yeah.
Okay.
Sorry, same thing with I talked from before as well, is supplier approval as well, and periodic sampling.
Okay. Any more questions? A few comments. Michael, Scott, thank you. Very informative. BG Ravi Kumar, thank you. Webinar was good and informative. And Tiffany, thank you for the webinar and answers. Yeah, that's. Any more questions? We've got 3 or 4 minutes to go.
Like I said, I mean, if people like the format, what we'll do is a bit of a presentation and then a Q&A on these food safety essential sessions. Next time, I've already got most of my presentation ready, and I'm going to talk about product labeling and undeclared allergens, which is causes masses of recalls in the food industry, and so it should be well worth coming to the next one in December. Yeah.
Super. Right.
Yeah.
I'm going to. Okay, so we will include the recording slides and this offer in the follow-up email that we'll send out to just this list. And also, yes, let me just put in, you do get a certificate. There you go. First ever food safety essentials certificate. Might be worth something one day, so treasure it. Download it, add your own name to it as usual. And yeah, there you go. Any more comments or questions before we go?
Thank you, everybody. It's been a good session.
Yeah.
Yep.
Great. All right, then. We'll leave it at that, and watch out for your emails for the follow-up for the next Food Safety Essentials. And thanks very much for your time today, Tony. That was great. Thanks.
Thank you, Simon.
All right. Cheers. Bye-bye.